Hello everybody! One of the most commonly used methods of finding cost drivers for reducing product costs is the method of factor research, or MFR. Within the framework of the general concept of MFR set out in the works of domestic researchers, we will analyze the list of control questions of MFR from the point of view of their applicable to structural and functional model of varying degrees of abstraction. As experience of practical use shows, the universality of MFR makes it possible to isolate the application of the basic method outside the framework of the value analysis. However, the features discussed in this video are relevant, including for such a case, since the abstractness of some of method control questions can cause certain difficulties of perception among practitioners. Consideration of control issues generally reflecting various concepts of reducing direct costs is carried out on the context in the subject of decision-making, conditional labor intensity, visualization tools, and etc. This video refers to Block 3 Cost Engineering as a section of value analysis of the Cost Engineering training course. As part of the discussion of today's topic, the following keywords will be used. I recommend the viewers of our channel to familiarize themselves with these keywords before watching this video. The tabular form that is used in MFR is quite simple. The left and central part of the tabular form contains the number of the control questions and 10 control questions. Generally speaking, I don't really believe in such beautiful coincidences, in particular the fact that by a lucky chance it's turned out to be 10 and not 9, not 11 or 13. Nevertheless, I propose not to depart from the already published list and content of questions, especially since they largely cover the list of possible cost drivers for reducing product costs. The only thing that has been changed in the table shown on the screen compared to the existing publications on the topic of MFR is terminology. Since we are considering the MFR in the context of the value analysis, the term detail has been replaced by the term element or function carrier that we introduced earlier. The right part of the table contains the name of the component and comment, containing the description of the cost reduction measure and the necessary explanations from the initiator of the designer, technologist, technician, marketer, cost engineer, and other member of the working group. Looking ahead, I will say that in column full name of analyzed component or function carrier, the structure of the component is actually entered in the accordance with its structural model and its degree of abstraction. Thus, in the case of an isolated application of method of factor research without the use of value analysis elements, we are faced with the need to decompose the component and form an analog of structural model. The bottom part of the table shows the final values of the expected economic effect from the implementation of the proposed measures, which are calculated according to the following formula. So, the first obvious disadvantage of the proposed technique is that all the reduction factors described in the first approximation to be considered equivalent in terms of possible effects, or within a given range from 5 to 10%. Later in the video we will see and consider cases when such an approach within the framework of the first approximation can lead to a significant error in assessing possible effects due to the fact that individual cost drivers can lead to cost changes beyond the specified range. Previously, we have already used the concept of lower and top-level abstract structural model to denote assembly units with a small number of elements and assembly units with a large number of incoming parts, aggregates, systems, respectively. For further reasoning and consideration of the classification of factors or control questions, cost drivers of reducing direct costs, it's necessary to narrow these concepts. So, the definition of lower-level abstract structural model shown on the slide can be stated in the following form, close to people familiar with the varieties of design documentation, in particular with the concept of specification in the United System of Design Documentation. The abstract structural model of the lower level corresponds to such a degree of abstraction in which each of its elements corresponds to the first approximation to the content of the specification of analyzed object. Indeed, indivisible elements, these are in fact the elements specified in the sections parts, purchased products and standard products of the specification document according to the GOST 2.106 2019. An example of a lower level abstract structural model is the abstract structural model of the eccentric or front wheel of a bicycle, consisting of two springs, for example, an axis and rotary lock, and an axis of a rotary lock and a plastic rotary head. i.e., for an eccentric that I think everyone can imagine, an abstract structural model consisting of 6 indivisible carriers of functions can be formed. An example not related to a bicycle can be an office paperclip, the structural model of which consists of 3 elements, 2 brackets, and 1 spring housing. Top-level abstract structural model is any abstract structural model with an abstraction level above the abstract structural model of the lower level. The need to introduce this classification is due to the fact that, for example, in control question number 4, it's possible to replace the blanks of elements or carriers of function with more progressive ones with smaller processing allowances. So we can talk about the preparation of a carrier function, a function carrier, only in the case of a lower-level abstract structural model. Since the complete structural model, there is 1 blank for all carriers of functions, and this factor is not applicable in the analysis process. And in the case of upper-level or top-level abstract structural models, there are several blanks in 1 carrier function at once. Therefore, this factor is also not applicable without additional decomposition into indivisible function carriers. In particular, adopted abstract structural model, in the definition of which was introduced by us in issue number 8, relate to top-level abstract structural model designed to improve the quality of visualization and use by managers in the decision-making process. I believe that listeners who have the ability to look somewhat ahead, either ahead of my narrative, have already come to the conclusion that this is necessary to determine the conditional status of the component. We are talking about nothing else than the need to solve the make or buy problem in relation to each of the carriers of function, i.e., in the process of applying the MFR, we need to understand what the supplier produces and designs himself and what he buys in finished form or in the form of semi-finished products. In order to clarify this issue, the make-buy column is provided in the standard form of method of factor research, which is mandatory since the wording of the proposed cost reduction measure in the comment column directly depends on the status of the make-buy column. The product developer can either use an already existing and put into production component taking into account the payment of royalties, or pay for or independently develop a new one. In the case of development of a new components, as a rule, the developer participates only in the formation of technical specification, and the working design documentation is developed by the designers, the supplier of purchased products, since they are all fully familiar with the equipment or the production site where the purchased product will be produced. In addition, in most cases, they have a rather narrow specialization, which allows they should carry out the work of development of future purchased products in a short time and at a higher professional level. Thus, In order to separate ready-made or not changeable purchased products from conditionally changeable purchased products, I developed individually for our project, and therefore, with our participation in the formation of technical specification, the column changeable, unchangeable is introduced. To summarize the above, in terms changeable and unchangeable mean the possibility or impossibility of making the changes in the design documentation of this component, and not the possibility of exclusion from the design documentation or replacement. Second, the main purpose of introducing the make, buy, and changeable, unchangeable columns into the form is to create restrictions to the process of formulating a description of cost reduction measure in the comment column. Okay, what about levels and criteria for solving the make-buy problem? Despite the fact that the consideration of the theory is a solution of make-buy problem is solving with the framework of management accounting, as a rule, quantitative method and value-added analysis are used. The content of the cost engineering course is not included. It should be taken into account that there is a direct link between the potential for reducing production costs and the distribution of make or buy in the product. Roughly speaking, if all components are purchased products, i.e., have the status of buy, which can be divided into non-changeable components of components, or components in the formation of technical specification for which we do not participate, and the changeable components, i.e., for which we first from technical specification. Then we will able to adjust the production costs of product with a limited number of tools, mainly through commercial negotiations, the effectiveness of which will mainly depend on the volume of purchases and market prices. Slightly on the availability of arguments in the form of calculations for similar products. Accordingly, when making a proposal to change the design in order to reduce costs and filling in the current column in the form of applying of method of factor research, we directly depend on the make or buy status. Let's consider examples of the practical application of MFR for structural model components of various degrees of abstraction. In particular, several elements of a bicycle, a bolt of complete structural model, a front wheel, a low-level abstract structural model, and bicycle or top-level abstract structural model. The elements of the complete structural model have been added to the initial data table. As well, an economic data for each function carrier. In this case, we are faced with another difficulty that arises when analyzing the complete structural model by the method of factor research, namely the fact that in ordinary commercial data, i.e. commercial proposals, as well in extended commercial data, i.e. complete or simplified calculation for a component, in this case, for a bolt, there is unlikely to be information that allows to distribute direct costs across function carriers. Therefore, we need a technological process for the component and the production calculations, which is possible only in the case of bolt production in our own production or internal production. In 99% of cases, the bolts is a purchased products or standard products that will be difficult to obtain the information necessary for the application of method of factor research. Accordingly, it can be concluded that the disadvantage of using method of factor research using complete structural model is the need for access to sharp production calculations for the analyzed component. Further, in accordance with the structural model of the object of analysis, the fields of the standard form of the method of factor research are filled in and either once in zeros put down for each of the control question. In the case of bolt complete structural models, there are not very many reduction factors. In particular, is the possibility of changing the quality of smooth part of the bolt from H7 to H9, the possibility of replacing the bolt material from steel 13 to steel 10, and changing the type of protective coating from zinc to cadmium, the assignment of ones and zeros, as well as filling the comment column. It's the responsibility of the members of the working group. The most common mistake at this stage is insufficiently detailed filling of the comment column. In particular, an example of incorrect filling in our case would be sounds like changing the quality, replacing the material, and changing the type of protective coating. You should fill in the fields only if there is an obvious logic that is understandable to all participants of the working group, i.e., if someone wants to enter an event but cannot formulate it clearly enough, such an event should not to be entered, because, according to the results of method of factor research, a pool of the most promising components will be selected in terms of potential for cost reduction in the design documentation of which changes will be made. Thus, the presence of non-obvious measures in the form of MFR may cause the formation of an incorrect pool of details. For making changes to the design documentation, in addition, attention should be paid to the availability of cost reduction options, the implementation of which leads to an increase in costs for other components. After feeding in all possible fields of the form by simple arithmetic calculations, we will get the first approximation of the magnitude of its possible economic effect of cost reduction measures. In the presented example of complete structural model, the expected savings from the cost reduction amount is to 4 rubles with a direct cost of 1 or 2 rubles, i.e. the expected savings is 3.66% with an expected effect from the event of 5% for the corresponding carrier function. In the case of forming a presentation on the use of method of factor research for company's management, you can work with a fork of values of the expected effect. For example, in the statistical value of the expected savings from one factor for each carrier function is equal to 5 to 10%, the expected savings can be formed from 4 to 7 rubles or from 2.66 to 7.33%. Consider the following example of the application of method of factor research. In this case, abstract structural model, we are dealing with a lower level abstract structural model. In the terms of filling out the form with the economic data, it can be noted that a rule information of this level can be obtained from the supplier, either in the form of calculation for a component or in form of extended commercial proposal, which indicates the prices of the components, with the exception of small elements usually combined in the commercial proposal under the designation Other. As can be seen from the example of using the method of factor research to analyze the wheel, the front wheel. However, this applies to the bolt and to the bike as a whole. There are no comments in this comments like replacing one alloy with another with worse fatigue characteristics can lead to decrease the resource of the node, or replacing more expensive bearings with cheaper ones can lead to decrease in the resource node, and etc. Excessive lyrical digressions like that we note are not included in the form of method of factor research, because we initially assume that the proposed cost reduction for the component meets the requirements of technical specification for the resource and the component, or for example the material of component that we replace had either a similar resource and characteristics, or resource and characteristics exceeding the requirements laid down in technical specification. Thus, we come to an important conclusion. proposals to reduce costs should not only be logically understandable, but also have an unambiguous financial justification, provided that the requirements of the technical specification are met. Questions in such situation, as a rule, arise from representatives of the marketing departments, since replacing, for example, a disc brake with a pincer brake may contradict the basic status of the market positioning of products. Indeed, visually the pincer brake is obviously inferior to the disc brake and causes for the consumer not quite the emotions that the brake system should cause when looking at this mechanism. In particular, due to the absence of a shiny brake disc with a large number of curly holes, a massive caliper that can be painted in aggressive sports colors. I'm not talking about the fascinating effects of a rotating shiny disc while driving. Such characteristics as modulation are unknown for most consumers. However, for those familiar with these characteristics, the diameter of brake disc and the size of the caliper also matter. The second difference from the first example in the presence of mutually exclusive measures, logical contradictions, within first control question, to reduce costs. In particular, we are talking about the exclusion of the camera from the wheel design and the installation of a tubeless tire. The effect of the exclusion of the camera is most likely correlated with the transition to a more expensive tubeless tire. And therefore the unit for the camera is not affixed. Ideally, the statement that the exclusion of one component will be correlated with an increase of the price of another should be supported by a report with a reference to the commercial offer. On control question number 3, which relates mainly to the competence of design engineers and stress engineers, the comments column present measures for changeable carriers of function and changing the thickness and requirements of nut flatness. On control issue number 4, which is within the competence of technologists, options are also presented for changeable components, bushing and flipper housing for replacing a blank from a circle with a blank from a forging, and for changing of weight of the roll used and cutting scheme. On issue number 5, related to the replacement of a structural material, proposals have been made for the comment column to replace LO6061 with LO7005, as well as to replace rubber R1 with rubber R2. For control issues from the 6th to 9th, not cost reduction options have been proposed, since they have specifics of applicability, more like for complete structural model. In particular, for assembly units simpler, that a bicycle wheel consisting of 2, 3, or 4 parts. As for control question number 10, several measures have been proposed, and as you can see in this case, in the non-changeable purchase products, they are in priority. However, these control questions will also apply to the changeable components if we decide to abandon their production and replace them with the purchased ones. However, in this case, the proposed event will require additional labor related with adjustment of the make or buy statement. In the presented example of a lower-level abstract structural model, the expected savings from the cost reduction amounted to 368 rubles, with an amount of direct costs of 20,820 rubles, i.e. the expected savings is 5.21%, with the expected effect of the event of 5% for the corresponding carrier function. In the case of applying a fork of values of the expected effect from 5 to 10%, the expected savings can range from 368 to 1,336 rubles, from 5.21 to 10.42%. The use of MFR in the process of analyzing the top-level abstract structural model is considered on the basis of an upper top-level assembly unit, which is in our case is a bicycle assembly. According to the results of filling out the form for the MFR, it's clear that we're voting of the measure possible for the first, second, fifth, and 10th control questions. Let's consider them in order. In control question number 1, a large-scale change in the frame design is proposed, in particular the transition from a full suspension to a hardtail. Perhaps some of the listeners who are not interested in bicycles will not able to appreciate the differences between these two design options. But taking my word for it, there is a difference, and it's very significant. At least it lies in fact that articulated joints are added, and the frame consists of not one but 3 welded elements. In addition, in this case, the frame is not longer required to absorb vibrations, since all vibrations will be absorbed by a rear shock absorber built into the structure. The following is a proposal to replace the spoke wheels with alloy wheels. i.e., we are actually replacing a system with shock absorbing and absorbing properties, spoke wheel. The system is more rigid by more technologically advanced in terms of balancing and does not require adjusting and tension of the spokes. With regard to suspension system, which includes the rear shock absorber and fork shock absorbers, it's also fashionable to say that dealing with a different physical principle, or replacing the working body of shock absorber from oil to air, as well as a significant change in operational features. According to control question number 2, the changes are rather of an operational nature, since the elements of lighting, ringing, and wings or shields are often not used by professional athletes. In general, this item on control questions 2 does not give us an idea of a different physical principle or change in power scheme of structure. However, cannot be considered anywhere except the highest level of abstraction, i.e. in the top-level abstract structural model. As part of the consideration of control questions number 5, a variant of replacing the structural material of the frame is proposed, which is primarily due to the fact that the frame is only changeable component, i.e. in this example we are dealing with a bicycle manufacturer whose make-or-buy concept implied the independent production if only the frame. All other bicycle components are purchased by this manufacturer from sub-suppliers. On control issue number 10, I believe no additional comments are required. Based on the commercial proposals of alternative suppliers, members of a working group, obviously procurement specialists or buyers, presented options for the purchase of cheaper purchased components, which is analogs of those that are currently provided for the design documentation. In the presented example of top-level abstract structural model, the expected savings from the cost reduction amounted to 3,431 rubles, with the amount of direct costs of 54,700 rubles. 54,700 rubles, i.e. the expected savings is 6.27, with the expected effects of the event of 5% for the corresponding carrier functions. In the case of applying a fork of values of the expected effect from the 5 to 10%, the expected savings can range from 3,431 to 6,861 rubles, or from 6.27 to 12.42%. The absence of logical contradictions between different control questions is another feature of application of the MFR. Let's consider similar contradictions of the example in the front wheel of a bicycle. In the comment field to the control question number 5 related to the possibility of replacing the material, it's indicated it's possible to replace the structural aluminum alloy 6061 with a cheaper alloy 7005. Nothing is indicated in the field control question number 7 related to the possibility of changing the manufacturing technology and configuration at the moment. However, if an event related to the manufacture of the bushing by high-pressure casting is included in it, then interdiction arises due to the fact that alloys 6061 and 7005 may not be foundry alloys. In addition, these points containing a contradiction increase the calculated value of the expected effect, i.e., mislead the manager who will make a decision on the implementation on the developed measures. The way out of the situation is the development of several versions of the report and the use of MFI in our case. The first version with a bushing made by machining, and the second with a cast bushing. What about MFI? Application context. The slide shows the context options for using the MFR. The first, isolated application in this case should be understood as the application of the MFR in the form in which it's presented in the existing literature. i.e., the cost engineer creates a form in Excel with formulas, fills it out together with the participants of work group of the analyzed object. The stage following the stage of analysis of changes in design documentation in accordance with the GOST 2.503/2013. However, due to the complexity of the problems arising at this stage, we will consider it separately in the video organization of the value analysis working group feasibility study of making changes in design documentation of block 3 for our course. The second, application in the context of the value analysis means a joint demonstration in the reports of the conduct of the value analysis of numerical values of functional deviations coupled with the results of application of the MFR. Thus, the customer of analytical work can get an idea of an expert assessment of the maximum functional deviations and MFR. Value of economic effect of the measures as well as magnitude to the effect that can be achieved by the isolated use of MFR. In more detail, the process of assessing the economic effect of eliminating functional deviations will be discussed in the video analytical reports and their interpretation. Current and functional deviations of Block 1. Within the framework of the classical presentation of the MFR, the authors, as a rule, limit themselves to the universal formulation of control questions, which we discussed above, without describing in the conditional instructions for use of the method of the possible context or practical application, both in isolation and within the framework of the value analysis. For example, in the case of an isolated application of the MFR, there's often such a phenomenon as abstract answers to abstract questions on the part of the members of a working group, i.e., a member of the working group indicates which component of the product one or more factors can be applied, but does not write explanations in the comments. In particular, to the questions, are there functional or necessary elements, may be indicated, yes, they are, but without specifying the comment themselves, perhaps with a note additional analysis is necessary. To the questions, it's possible to replace the material with a cheaper one. It's possible to combine several elements into one, etc. Similar unfounded answers are possible except for expert opinion. With such an approach, the effect of using the MFR in the process of forming an action plan to reduce direct costs for the product can be either estimated incorrectly or reduced to zero. In the case of an isolated application of the MFR, such a case can lead to dead end, since there is non-functional model of the components, but in the case of use the MFR in the context of value analysis, the specific conclusion can be made on the basis of functional model about the functional useness of the product component. Following the logic, we come to the conclusion that in process of analyzing the components of the product in the context of factor control issues, it's possible and moreover it's highly desirable to use structural functional model components, without which the indication of cost drivers will be supported not only by expert evaluation, but also prepared with the participation of structural and functional model experts on the object of analysis. Based on the analysis of three objects of different levels of abstraction, complete structural model, abstract structural model of lower and top levels, as well as taking into account the experience of using the MFR in my practice, a table of applicability of control questions has been formed, which is absent to the classic presentation of MFR. In the column of the table applicability, for each of control questions, the data obtained within the framework of above analysis of components of various degrees of abstraction are compiled, i.e. it's actually indicated which is the control questions can be applied depending on the degree of abstraction of structural model, components of complete structural model abstracts at lower and upper levels. The column blocked of table formation of cost reduction measures, typical indicator of the event is indicated from among the members of working group. The cost of products or its components corresponding to the control issue, i.e. in fact this table carries part of the RASIC functionality. In the remaining columns of this block, typical performance of work related to the analysis of feasibility of this cost reduction measure and subsequent changes to design and other documentations are indicated. Since universality of method factor research allows to be applied both at the stage of project and the stage of work in design documentation, the column stage of application of method factor research contains information corresponding to all 10 control questions. In the table column block visualization tool, there are two types of tools that can be used to form an event corresponding to each of 10 control questions. Typical tools from the toolkit of cost engineers, i.e. value analysis tools and structural and functional models. The tools used by other specialists, the working group is characterized by a somewhat greater variety, starting from software for 1D modeling in control question number 1, which has a significant degree of abstraction, ending with software products for 3D modeling, stress calculation, writing technological processes, and so on. In the column blocked examples of function carriers, examples of real objects corresponding to the degree of abstraction of control questions are given. For example, for control question number 1, examples may be an aircraft control system in which the control element is implemented using various physical principles, either to the form of joystick or transmission of an impact for the form of electromagnetic signal, or in the form of steering wheel or mechanical transmission of impact. A bicycle brake system implemented either using mechanical force transmission cables or by means or incompressibility property of brake fluid, hydraulic pressure, etc. In the case of control question number 2, an example of functionality unnecessary elements for complete structural model may be stamping on a plastic part for abstract structural model, the mechanism of crooked starter in the car, an ashtray in the cabin of aircraft, a CD-ROM in a laptop, and etc. Based on the results of the formation of the table of applicability of MFR to structural model of varying degrees of abstraction, and in particular filling in the column subject of the event formation, we can conclude that the following distribution exists. The possibility of reducing costs by 50% degrees by the design engineer, by 20% on technologists, and 20% cost engineer, and only 10% from a buyer. Of course, these conclusions relate exclusively to the method factor research and are approximate, but they are indirect confirmation that the role of specialists in the field of economics and procurement in buying, and the formation of the cost of a product should not be overestimated, and the role of design, engineering, and technologists, in turn, it's often underestimated. Thus, it can be assumed that the most important stage in the formation of cost of the product is the stage of development of the project design documentation, like technical proposal, preliminary design, technical project, and other project design documentation, at which it's necessary to interact cost engineers of first and second types with design engineers, not in the format of meetings, but in the format of joint value design engineering, which implies the integration of cost engineers in the organizational structure, i.e., in fact, the integration of cost engineers into the design engineering departments, as well as formation of a database of applications to design documentation, like structural and functional models, analytical reports, and etc. And this database allowing to access the current status of costs for the implementation of consumer and other functions in comparison with the competitors' analogs and products of the previous generation. If necessary, apply such tool as a method of factor research. Let's consider an example of using the MFR in the process of analyzing the design of a bicycle. In particular, the option of replacing non-standard fasteners, drawing bolts and nuts made by machining, for example, turning or landing, with standard fasteners. See control questions number 8, i.e. fasteners made by powder metallurgy methods, and etc. That the drawing fasteners had a production cost of 100 rubles and their updated cost to 70 rubles, i.e. according to the results of measures, the cost decreased to 30%. Consequently, we are leaving to the RF coefficient or reduction factor range from 5 to 10% proposed in the literature on the MFR. An analysis of real calculations, for example, in general mechanical engineering, shows that the above assumption is not far from the truth. Taking into account the above, we come to the conclusion that the minimum necessary of modification of MFR include the use of MFR using the output data, initial data of value analysis, due to the low efficiency of its isolated application, in particular due to the inability to use structural and functional model components of the product. The second, the need to classify the structural model of the object of analysis, i.e. determining which step it belongs to: complete structural model, lower level abstract structural model, or top level abstract structural model. The third, presence of additional initial data in the form of extended calculations, cost breakdowns for the components of the object of analysis, i.e. when the object of analysis is decomposed in the components for each of them, it's not enough just the value of its purchase price indicated to the commercial offer or direct costs indicated in simplified calculation for the product. In this case, a calculation is needed for the to be analyzed component. In this above case, for a bolt, which allows you to more accurately determine the possible value of the RF coefficient, the average result of one reduction factor. In fact, the more detailed the calculation for analyzed component will be at our disposal, and more accurately to the value of the RF coefficient can be determined. Okay, let's conclude all this information. The maximum effectiveness of the use of MFR in terms of assessing the possible effects of cost reduction and achieved by analyzing the component at 3 levels, sequentially in the following order: top level abstract functional model, lower level abstract structural functional model, and complete structural model, i.e. actually using by deductive scientific approach or analog of this approach. The second, the minimum complexity of the use of MFR can be achieved by forming a lower-level abstract functional model due to its universal applicability. However, if the components of the lower-level abstract functional model have a complex configuration, brackets, housing, stats, additional analysis may be required for each of them using the MFR at the complete structural model level. I suggest we end this for today. Put likes, subscribe, all bye.